There is a moment every evening, just after the last forager returns, when your garden becomes irrelevant to the hive. She lands at the entrance, passes through the guard bees, moves into the warmth of the colony. The flowers she found today, your lavender, your clover, whatever was open and worth visiting, exist now only as information inside her. The routes she flew, the distances, the direction from the hive, the quality of what she found, all of it is encoded in her nervous system, waiting to be transferred. The garden is quiet. The hive is not. Most people have never thought about what happens inside a beehive after dark. Why would you? It hums during the day, the bees go in and out, and at some point in the evening the traffic slows and stops, and you assume the hive goes to sleep the way everything else does. Dark outside, dark inside, a collective rest, and then tomorrow. That assumption is wrong in almost every important detail. What happens in the hours between the last bee returning and the first bee leaving tomorrow is one of the stranger and more complex biological processes that occurs regularly in your garden without your knowledge. And one part of it, the part that involves what happens to the memory of your flowers in the brain of a sleeping bee, is the part that I have not been able to stop thinking about since I first understood what it actually meant. If you're new here, subscribe before you go. New video every week. Stay until the end. There is a detail in the last section that changes the way I look at my garden in the morning, and I think it will do the same to you. The hive at night is not dark. There are no windows in a natural bee colony. The cavity in a tree or the wooden box in your garden is lightless from the inside. But the darkness is the only quiet thing about it. The temperature inside a healthy hive is held at 35 degrees Celsius, year-round, day and night, with a precision that most controlled laboratory environments would find difficult to match. Holding that temperature requires effort, and effort in a bee colony means workers. Some bees fan their wings at the edge of the colony structure to move warm air through the cells. Some press their bodies against sections of comb that have cooled slightly. In winter, bees form a cluster and generate heat collectively, the bees on the outside rotating inward as they get cold, cycling through the center where the warmth is highest. In summer, different bees carry water into the hive and spread it across the cells, cooling the interior through evaporation, fanning constantly to move the moisture-laden air toward the entrance. The hive is never not working. At any given moment in a healthy colony, there are foragers who have just returned. There are house bees processing the day's pollen and nectar. There are nurse bees attending the brood. There are guard bees at the entrance, even at night, less active but present. The colony never fully stops because the colony is the organism, and organisms don't turn off. But within this, something specific happens to the foragers. Something that took researchers many decades to identify, partly because the idea that insects sleep, that bees specifically sleep, was not taken seriously until the evidence became difficult to explain any other way. Bees sleep. Not in the metaphorical sense, not in the sense of reduced activity. They sleep in a way that produces changes in their nervous systems, that consolidates memory, that impairs their behavior when it is prevented. They sleep the way you sleep, except in short cycles across a 24-hour period, rather than one long block, and with their antennae drooping in a characteristic posture that experienced beekeepers recognize on sight. A sleeping bee in a hive looks exactly like a sleeping bee. And what happens during that sleep is the part that changes everything. Research conducted at the Australian National University in Canberra, published in 2008, took a group of forager bees and systematically prevented them from sleeping. Not from resting, from completing the deeper phases of sleep that produce the specific physiological changes associated with memory consolidation. The method was precise. Small mechanical vibrations delivered at intervals calibrated to interrupt sleep cycles without causing physical harm or preventing rest entirely. The bees were tired but functional. The next morning, researchers observed how these sleep-deprived foragers communicated the locations of food sources to their colony mates. Bees communicate location through the waggle dance, a figure-8 movement on the face of the comb, where the angle of the straight run indicates direction relative to the sun, and the duration of the waggle indicates distance. The code is precise. Other bees read it to navigate to the flower patch. The sleep-deprived bees danced inaccurately. Not wildly inaccurately. The dance was recognizable, and the general region indicated was approximately correct. But the precision, the specific angular data and timing that would allow another bee to fly directly to a flower patch rather than search the general area, was degraded. The bees who had been prevented from sleeping were giving their colony imprecise directions. The routes they had flown the previous day had not been fully processed. The memory had not consolidated. Which means something that took a moment to land properly when I first encountered this research. The forager sleeping in your garden's hive tonight is not simply resting. She is processing your garden. The specific flight path she took from the hive to your lavender, the direction, the distance markers, the landmarks she used to navigate, is being consolidated in her nervous system right now. When she dances tomorrow, what she communicates will be the result of that processing. The accuracy of the directions another bee follows to find your flowers depends on what happens in the brain of a sleeping bee the night before. Your garden is, at this moment, being integrated into the colony's navigational memory. There is a second layer to this that involves the hive's collective response to what individual foragers bring back. A forager who returns with high-quality nectar, high sugar concentration, abundant supply, easy access, dances with more intensity and duration than a forager returning from a mediocre source. Other foragers observe these dances and make decisions about where to go the next morning. A patch that multiple foragers are dancing for enthusiastically will have more bees recruited to it than a patch being reported by a single bee with a low-energy dance. The colony is continuously integrating incoming reports and adjusting its distribution of foragers based on them. This means the overnight period is also a period of collective recalibration. The reports from yesterday's foraging, which patches were productive, which were not, which ones have been danced for by returning bees, inform where tomorrow's foraging effort goes. The colony does not make this decision through any central authority. There is no planning meeting. No single bee evaluates all the data and issues instructions. The decision emerges from the aggregate of individual dances, each one contributing information, the whole thing resolving into a distribution of attention across the landscape. And that distribution includes your garden, or not, based on what the bees who visited it yesterday brought back, and how enthusiastically they danced about it when they got home. This is not a small thing. A hive typically covers a forage area of several kilometers in radius, an area that can span thousands of individual gardens, parks, agricultural fields, hedgerows, and wild spaces. Every day, the colony is making resource allocation decisions across that entire landscape. Every night, the data from the previous day's foraging is being processed, consolidated, and integrated into the next day's strategy. The fact that a bee found your flowering rosemary last Tuesday is information that has, in some form, been distributed through the colony's collective awareness. They know your garden. Not the way you know it. Not with anything like your understanding of what it is or what it means. But they know it the way a distributed navigational system knows a resource, as a location, a quality, a direction, a distance. Now the 6 weeks. A forager bee lives approximately 6 weeks from the day she first leaves the hive. In that time, she will fly the equivalent of 1.5 times around the circumference of the Earth. She will visit hundreds of flowers per foraging day. She will produce approximately 1/12 of a teaspoon of honey across the entirety of her adult life. At the end, her wings will be visibly worn, the membranes frayed at the edges, the structural rigidity reduced by thousands of hours of friction against the air. She will die on a foraging flight and not come back. Every night of those 6 weeks, she sleeps. Not once, not in the long, sustained way that we sleep, but in cycles, short intervals of deep rest distributed across the night and into the quieter periods of the day. And every night, the memories of that day's foraging are being processed. Think about what that means across the span of her life. The routes she learned in her first weeks, the ones she flew when she was new to foraging and the navigation was still unfamiliar. Those memories were consolidated in sleep, refined over subsequent nights, updated when she found better sources, deprioritized when old patches stopped producing. The version of the landscape she carries by week 5 is not the version she had in week 1. It has been updated continuously, each night's sleep doing the work of integrating that day's experience into the map. She is, in the most literal sense, a different navigator in week 5 than she was in week 1. Not because her brain has physically changed, though there is evidence that repeated navigation does produce structural changes in the regions of the bee brain associated with spatial memory, but because the accumulated processing of 40-plus nights of sleep has built a navigational representation of the landscape that week 1 her did not have. She never sees the whole map. She cannot. But she has contributed to the colony's version of it every day she has flown and every night she has slept. By the time her wings wear out, the version of your garden that lives in the hive's collective navigational memory has been shaped, partly, by her. Right now, while you're watching this, the foragers from the hive nearest your garden are sleeping. Some of them visited your flowers today. Whatever they found, the concentration of nectar, the accessibility of the pollen, the ease of landing, the distance from the hive, is being processed in the hours since they returned. Whether they dance about your flowers tomorrow depends partly on what happens in their nervous systems tonight. I find something in this that I cannot quite flatten into a straightforward summary, which is the mark of an idea that has been real work to absorb. We tend to think about the relationship between our gardens and the bees that visit them as a transaction. The flowers produce nectar, the bees collect it. They pollinate incidentally. The exchange is simple and transactional and complete when the bee flies away. But the bee flying away is not the end of the exchange. She carries your garden with her. She brings it back to a colony that will process it, evaluate it, integrate it into a distributed decision-making system that runs continuously across 50,000 individuals. It will be consolidated in sleep. It will influence tomorrow's foraging decisions. It will, if the source is good enough and the dance is enthusiastic enough, bring more bees to your garden the following morning. Your garden does not disappear from the hive's awareness when the last bee leaves it. It enters a processing system that runs through the night and produces navigational instructions that will be followed the next morning, with the same precision a pilot follows a flight plan. It becomes part of the colony's model of the landscape. It persists, as information, in the nervous systems of sleeping bees and in the aggregate behavior that emerges when those bees wake up. This has been happening every night this summer, every night last summer. Every summer there has been a hive within flying distance of wherever you live and a garden with something worth visiting. The hive has been maintaining a record of your garden. You didn't know. You were inside and the lights were off, and as far as you were concerned, the day was over. And out there, in the dark, in a structure that never fully stops, small creatures with brains the size of sesame seeds were sleeping on their routes through your flowers. Go outside tomorrow morning and find the first bee. Watch her for a moment before she finds the flower she is looking for. That fractional hesitation, the adjustment of trajectory, the moment before she locks onto the target, that is the end result of a process that started last night when a bee very like her went to sleep. She is flying a route that has been processed and consolidated. The flower she is heading toward is not a discovery she is making now. It is a destination she was already pointed at before she left. She is an implementation of decisions made overnight by a system she is part of but cannot see in its entirety. She knows where she is going with a precision that took multiple nights of sleep to build. The flower she lands on was, in some sense, decided while you were sleeping. I have stood in my garden in the early morning more than once since I understood this and watched the first foragers arrive. They land with a specificity that is almost unsettling, not searching, not wandering, but arriving, as though they had an appointment. They did. The appointment was made last night in a hive I cannot see by a process I cannot fully follow, while both of us were asleep. That's what a bee is. Not an insect that visits flowers. A node in a distributed intelligence that models the landscape while you sleep and sends its agents out every morning to act on what it has learned. Your garden is in that model. I don't think that's a small thing to know. Leave a comment and tell me, did you know that bees sleep? I didn't until a few years ago. And the first time I watched a sleeping bee, antennae drooping, completely still in the comb, I didn't believe what I was seeing. If you've ever seen one, tell me what it was like. I read everything. Subscribe. New video every week. See you next time.